So today, we're going to talk about routers. No? Puro tayo routers. So we can forget about switches kasi we performed that one in our previous class. Okay, so how's my audio? Malinaw ba or medyo choppy?
Clear naman, sir.
Malinaw, that's good, that's good.
Clear,
So I'm
sir.
gonna increase the volume. Ayun, naka 46 lang pala ako. Yan, in-increase ko, medyo lumakas na. Okay, hello. Yan,
Sir,
yan.
yes sir,
Okay.
malakas na.
Malakas na. Good. So, introduction to dynamic routing protocol. So, roles of dynamic routing protocol. So, exchange of routing info between router. Okay, so the main responsibility of a router is to exchange information from router 1 to router 2 to its final destination. Okay? As you can see the arrow, so meron siyang direction, no? Tinatawag nating vector. So dynamically learn info about remote networks and add routes to the routing table. Let's say, for example, the router said hello to the neighboring router. It will pull up information from the neighbor router. Okay? It also determines the best path to each network. Let's say, for example, you have router 1, 2, and 3. What is the nearest path? So, of course, yung direct point-to-point from R1 to R2. What will be the longest path? So, of course, from R1, R3 to R2. Ganun, no? So, another responsibility is it automatically finds alternate path if needed. Let's say the path here has been unreachable, no, for some reason, it will do a recalculation of the path. Okay, so tawag doon is path determination. Advantage over static. So with dynamic, it's less admin overhead. Whenever you create a route here, this will be dynamically learned. Kasi if you broadcast niyan to its neighboring router. Now, number 2, it scales better. The moment you add a router, and the router will learn all the routing info from the routing table, no need to manually enter. Okay? And of course, it's less prone to configuration error. Kasi you don't have to type manually on each router. No? You don't have to type. Okay? So less prone to human error. Net discovery in routing table. So meron siyang components of routing protocol. First, data structure. Second, algorithm. Third, routing protocol message. So when you say data structure, ito yung flat table, no? Or database for their operation. It is kept in memory. Okay? So that's why if you forgot to save, then reboot, it will be erased. So later on, you will experience. Kasi sabihin nyo, sir, nalimutan ko mag-save. Kasi naka-RAM lang yan. No? So it's very volatile, nabubura. Next component, algorithm. Okay, algorithm. So algorithm is a finite list of steps used in accomplishing a task. So meron siyang step by step, no? Meron siyang fina-follow na protocol, no? Let's say step 1, broadcast, step 2, learn, step 3, block, mga ganun, okay? Another thing about algo is it is used for processing routing information and for best path determination. As I mentioned kanina, meron siyang tinatawag na recalculation in case the first link or yung original path is unreachable. Third component is routing protocol message. So, ang message na to usually is a hello message. No? So, what is hello message? Hello message used to discover neighboring routers. So what do you mean by that? Let's say, I would like to find out if router 2 is up and running. So in router 1, for an X number of seconds, we'll be sending hello packets. Okay, sabihin, hello, pare, up ka ba? Pare, down ako. So sorry, hindi ako pwede magamit. So pag down yan, once unreachable, it will do a recalculation. Sabihin niya, pare, open ba yung gate mo? So dito ako dadaan. Okay? So anong tawag doon? So discovering neighboring routers, hello packet. Okay. Next is exchange. It learn and maintain accurate network routing info. So once you say hello, it will discover kung ano yung MAC address, ano yung routing table, or whatever database stored on the next router. Then, the-download yan. No? Tawag doon, acknowledgement, and then copy. So, kakopy niya dito yan. So, tawag doon is dynamic learning. Okay? So, tatlo yun, 3 components. Data structures, algorithm, and the message. Next is classifying dynamic routing protocol. So, meron tayong tinatawag na inferior, no, which is used local area network or LAN, or exterior, which is used if you want to connect to the outer LAN, which is WAN, could be MAN. No? So, exterior, papunta nga yung spin short. Interior, within the same building. No? Interior gateway protocols. So, meron akong definition yan if you would like to find out. No? So, interior, IGP, is a protocol for exchanging routing info. So, what do you exchange? The routing info. So, inside the info, may mga tables. Okay? Which records the routes. Okay? So, for exchanging routing info between gateways, host with routers, within the same autonomous network. So, when you say same autonomous network, what do you mean by that? Anybody? Adrian? Autonomous network, what do you mean? Local area network.
Local area.
Oo, yun. Local area, no? Nasa screen. No? So, ganun ako mag-question. Ano? Sa lahat ng question ko, actually, nasa screen lang. Next is exterior. So, EGP. When you say exterior, it's a protocol for exchanging routing info between 2 neighbor gateway. Okay? So, ibig sabihin, dalawang gateway, either from your office or to PLDT. Okay? The network of autonomous system is commonly used between hosts on the net to exchange routing table. No? So, it will be routed externally, papuntang internet. Okay, balik tayo dito. Inside, malinaw ba? Interior, exterior. Saan ginagamit interior? For LAN. Exterior?
Outer.
For WAN. Okay. Under interior, merong protocols, 2 protocols. First one is distance vector. Second one is link state. Puntahan muna natin yan. So we need to identify naman itong distance vector na sinasabi niya. No? So when you say distance vector, routes are advertised as vectors. So when you say vector, it's a distance and direction. So merong how far it is, okay? And then saan pupunta? Whether you go to interface 01 or 00, no? So distance is defined in terms of a metric. So meron tayong metric. Ang one metric example is hop count. So when you say hop count, this is the number of routers between the source and destination networks. Okay, I'll give you an example. So, pupunta ako sa command prompt ko. I will do a tracer papuntang ABS-CBN. Okay, so ito yung number of hops. So, the first IP was is my gateway, 192.168.1.1. Ito yung D-Link router ko. Okay, 1.1. Then, this is my ISP. So, first hop ko, ISP. Sino yung first hop ko? ISP. If you can see, tpg.com.au. So this is in Sydney, GLS global location, no? Sydney global location tpg.com.au. Kasi ito yung ISP ko. So ano yung first hop ko? ISP. So I'm connecting using exterior gateway protocol, okay? And then next hop ko will be static tpg, then bundle ethernet edge. So this is the edge router. So yung TPG dumadaan sa telstra.net. Okay? So saan dumadaan? Telstra.net. Kasi sila yung probably may gateway to the rest of the world eh. So Sydney Telstra.net, Sydney Telstra.net, tapos meron siyang CLO, could be a core router linked to Telstra. Okay, so itong Telstra na to could be somewhere in Australia kasi if you can notice 20350, no? If you do see my IP, it will tell you kung nasan siya. And then, nag-jump ka agad dito sa gateway ng ABS-CBN. Okay? So, trace complete. So, ilang routers yung tinalunan niya? Ang dami, di ba? Ang dami. Ang dami. Bilangin natin. 9 hops. Okay? 9 hops. Malinaw, 9 hops. So, what is hop count? Hop count is the number of routers between the source, which is my computer, to ABS-CBN. Okay, so naka 9 hops ako. Could be 9 routers or could be less than, could be more. Kasi iba naman, hindi i-expose yung IP nila, no? Sometimes they are proxy na naka-hidden sila. So, hindi accurate na 9 routers, no? So next, distance and direction is the distance vector is direction. Is simply the next hop. Okay, simply the next hop. So what do you mean by next hop? Tatanong ako, Christian, what is next hop? Christian, what is next hop?
Next up is,
In my case, sino yung next hop ko? Kasi LAN to, di ba? So sino yun akong pinuntahan?
GPI.
Si? Sydney, TPG. Kasi ISP ko is TPG. I'm paying $90 a month, no? Sa TPG yung pinuntahan ko. Okay? So, yan yung next hop. Okay? So, how many direction I have? So, if someone asks you, how many direction I have? Now, so, when you say direction, it's simply the next hop or exit interface. No? So, in direction ko is, let's say, fast Ethernet 00. Ito yun. Papunta dito. No? How many hops to go there? Yun naman yung distance. No? So, distance is measured in metrics. And one metric example is hop count. So, distance ko will be, ilan? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So, yun ang distance ko. Pero not necessarily really 9. Na? Could be more. As I mentioned, hidden ng iba. Next is the routing updates. Usually consists of periodic updates of the entire routing table. So meaning probably every 10 seconds, 5 seconds. No? Sa RIP, if you're gonna be using the basic routing info protocol, which is RIP, every 30 seconds. Okay, nag-update. So what do you mean by that? So ganito siya. Every 30 seconds, nag-hello packet siya. No? So let's say R1, nag-set na hello. No? The next hello will be after 30 seconds. Okay? Malinaw ba distance vector? Ano metric ng distance vector, Alec? Give me one example of metric ng distance vector. Yung kaninang lesson, hop count. Okay, hop count. Okay? So, next is the link state protocol. So, when you say link state, puntahan natin to. Link state. So, a link state, am I recording? I want to make sure recorded. So, yeah, recording. A link state routing protocol can create a complete map of the network topology. Okay? So, this will create an auto mapping. Okay? A link state router, no, normally receive update from the neighbor. No? Coming from the neighbor, it will build a topology database. So, saan galing database? From the neighbor. Okay? Link state uses shortest path first algorithm. Okay? I'm gonna discuss later na yung SPF to create its view of the network. So, anong algorithm kine-create ng link state? SPF. Shortest path first. Link state builds the routing table. So, who's the one responsible for building routing table? Link state. Okay? So, anong algorithm ng link state? Shortest path first. Okay? Routing updates, not the entire table, are only sent to neighboring routers when that topology changes. So, when you say updates, not the full database. Okay? That's why mabilis siya. Kasi hindi niya sinesend lahat ng information. OSPF is open shortest path first. No? It came from the algorithm called SPF. Okay? So, anong algorithm ginagamit ng link state? Shortest path first. So, that's why ang protocol dito is OSPF. Open shortest path first. Ano ulit algorithm nito? Shortest path first. How does it learn the routing table? No? By sending updates every 30 seconds. Okay, I'll give you an example. So let's say you have topology change in link state update. So first, it will process first router to update this routing table. Second, it will send a broadcast to the next router, process to update this routing table, and send. So in short, this is parallel. Okay, can be done via parallel. What about in series? So let's say you have 3 routers. You have, let's say you're receiving info from W. Okay, this is a left. And then you will be saving that routing information in your routing table. And then A will send update via hello packets then, no, to router B. So B information will originate whatever routing information written on the routing table from router A. Okay, ganun. No? So in short, one by one, no? Dadaan ka muna sa A. Let's say info nito is 10. Dito 8 lang, dito 5 lang, no? Pag binroadcast nito yung 10, ma-recognize niya, meron siyang missing 2. So yung missing 2 will be added to the routing table. Malinaw ba? Then let's say routing table router C is meron siyang 5. Since naka-receive siya dito ng 10, how many will be updated? Actually, 10 pa rin. No? Ko-compare niya ano yung missing sa table na yun. Then, it will come to a term called fully converge. So when you say fully converge, all routing information has been replicated from the origin to the destination, no? Fully converge. So that's the time he will send an acknowledgement. Okay? Magsisend niya ng acknowledgement. Ngayon, different protocol has different algorithm of sending acknowledgement. No? Iba-iba yan. So later on, makikita ninyo, paano siya nag-acknowledge? How will you say na nandito na ako? Di ba? Okay? So, distance vector, meron siyang protocol classful, which is RIP, and classless, which is RIP version 2, and EIGRP. So, sa examination, we're gonna be concentrating dito lang. Okay? Pero pag-aaralan pa rin natin iba. No? So, what do you mean by classful and classless? Sa classless, it's using VLSM and CIDR. So, what do you mean VLSM? Variable length subnet mask. So, meaning, the way he broadcasts traffic is more efficient kasi he's not using the full class. Let's say, class A. Class C. How many IP address can you broadcast in class A? Diba yung /24 has 254 IP addresses? Paano kung users mo is 10 lang? So, ang daming na-waste. Na-waste ka ng 244 IP addresses. Okay? So, yun yung class full. Sa classless, it's more efficient. No? Pag sinabi mo /30, you can have 4 IP addresses. No? Usable, dalawa lang. So, that's why meron kang dalawang IP available to put into your router. Okay? So, anong difference ng dalawa? Classless is a efficient way of addressing IPv4. No? It's using a slash notation, CIDR, and VLSM. Classful is using class ABC, no? Which is a waste of IP addresses, not really efficient. Pag binato mo, broadcast sa class, let's say B, everyone will be listening. Okay? So we're gonna go EIGRP RIP to one by one. Okay? Yeah. Let's compare routing protocol. So this is summary, no need to study kasi sinamarize na. Wala na kaming long discussion na tulad dun sa Ortigas Center office namin. Nakaabot kami ng 8 oras sa isang araw. So dito, summarize na. Okay? So version 2, is it classful or classless? John Arvin.
Classless, sir.
Galing. Using VLSM / notation. Tama. No? Okay, so it's a distance vector which means meron tong metric na tinatawag na Sir Mark, meron siyang metric, distance vector. Ano kayang metric ito? No, meron siyang metric na tinatawag na yung parang talon. 'Di ba?
Hop.
Galing. Hop, tama. So meron siyang metric, hop. Okay? Same with the AGRP, metric na hop. Meaning, if you're gonna be using, let's say, different protocol like RIP, no? The less hop, meaning this will be the best path. Okay? If you're gonna be using RIP. Then OSPF is link state. So again, what is link state? Ito yung may shortest path first, no? Not necessarily the nearest, pero the one with the fastest bandwidth. Okay? Tandaan nyo yun, ha? So, ano difference ng distance vector sa link state? Link state prefer the one with the fastest bandwidth. Let's say ganito. Saan na ba yung demo? Ayan. So, actually, may demo ako mamaya. Ayan. So, R1 to R2 is R1, R2 to R3, 1, 2 hops to R3, no? Ba't di ka na lang tumawid dito from R1 to R3? So, yun ang shortest hop, no? I mean, minimal hop. So, if you're gonna be using RIP, shortest hop. Now, if the speed here is 64 kilobit, okay? Dito naman 1.5 megabit, 1.5 megabit. Mas mabilis yung pag di ba? So, yun ang link state. The one with the fastest bandwidth wins. Okay? Kahit malayo, pero mabilis naman. And if you implement OSPF, it will follow this protocol. Nagets niya? Okay? Later, I'm gonna explaining again kung ano yung RIP and so on. Okay? So, tandaan nyo lang, link state, more concerned about the speed. No? AGRP is a hybrid. Hybrid to AC-DC to. Could be the one with the fastest bandwidth or could be the one with the lesser hop. Basta RIP2, less hop. No? The more hops, the less efficient. So meaning, konting hops, pinakamalapit sa kanya. Okay? So meron tayong IPv6. So these are all 1 to 8-bit. Okay? So wala na ditong broadcast. It's more efficient because it's using multicast. So what do you mean by multicast? Multicast is one to group of many. Okay? Pag nag-unicast ka, that's why dito sa classless, nag-unicast tayo, meaning one-to-one. Ibig sabihin, if you pass the traffic from this router, unicasted dito lang yung traffic. Hindi ka pwedeng bumato dito. No? Usually used to point-to-point connectivity. Okay, so this one is IPv6. This is a very obsolete one. So actually, ginagamit pa yan sa CCNP. BGP is used for ISP. Okay, so wala tayong topic for ISP. Tinanggal na yun sa CCNA 200.301. So wala tayong border gateway protocol. Sa lumang examination, meron daw. Meron na nag-exam. Okay. So again, interior, exterior. Again, ano itong interior? This is short for, Nico? LAN. Okay. Exterior, ninyo? 1. Okay?
1.
Ba tayo bumbaking cursor? Distance vector, anong, what do you mean by distance vector? It has distance and direction. Okay? May distance and direction. The one with the shortest hop wins. Link state naman, shortest path first, meaning the one with the fastest bandwidth. Okay? So, ganun, no? Ganun sa klase, inuulit-ulit ko. Kaya pumapasa yung mga student. Okay? Paulit-ulit lang kami. Walang kasawa-sawa. Next, classifying dynamic routing protocol. So IGP versus EGP. So when you say IGP again, LAN. So you could be running RIP protocol dito, OSPF dito. Dito naman RIP, AGRP and so on. Could be hybrid. Pwede yan. They can communicate to each other locally. Now, what if you would like to send file sa Amerika? So tatawid ka na syempre ng ISP. In this case, meron ditong PLDT, Globe, or Smart. No? So tawag dito sa communication na to is Border Gateway Protocol, EGP. Okay? So when you say BGP, connects to autonomous system. Okay? Autonomous system 100, which is assigned by IANA, and autonomous system 200, which is assigned by IANA. So in our past lesson, na-discuss ko na yung IANA, no, IPv6. They're the one managing the IPv6, IPv4, and autonomous system. So each site, merong AS number. Now, so AS number, to pass to AS 200, you need to define that route. Else, they won't be able to communicate. Okay? So dito naman sa EGP, you are allowed one autonomous system to exchange routing. So meaning, the whole site should have be given an AS number. No? Could be by PLDT or could by ISP. Okay? Allow routers within an AS to exchange info. So meron dapat dito sa router na to, before they can exchange, meron ding AS, autonomous system din. A-assignan natin. Okay, so ganito lang pag-aaralan natin. So wala muna tayong pakialam sa exterior. So we can focus more sa OSPF. Okay? So yan yung mga na-discuss ko. Yan. Link state. Okay, so summarization. When you say summarization, it's more efficient way of distributing the broadcast, no, or the route. So I'll give you an example. So let's say you have route, let's say net, you would like to broadcast to 192.168.10.0 subnet. Okay, so I'll make this one more visible. Okay. So this is with summarization. Okay, so first broadcast sa subnet 10, second broadcast sa subnet 20. Could be nandito yung Wi-Fi. And then sa subnet 30 naman, could be nandito yung LAN. Okay? And then subnet 40 could be nandito yung mga sales team. Okay? Then subnet 50, nandito na may marketing team, no? So we are doing segmentation in short, no? So dapat may kanya-kanyang routes for each subnet or each VLAN, no, to isolate traffic. Ngayon, if you're gonna implement summarization, you need to make the router address a more efficient way para sa kanya. Kasi bilangin nyo to, ilang routes yan? 5 yan, di ba? Okay, 5 yan, di ba? Okay, 5. Sabihin na natin 50. Okay? Palo na CPU mo, so 1 core. Okay, papalo yan. Let's say, for example lang, 50%. No? 50% CPU. Paano kung 100? E di 100% CPU. Kung ano 100, pumalo. You monitor via PRTG or SolarWinds. No? Wala na. Babagal na yung routes. Okay? Hindi efficient. So in short, not efficient. But secure. Okay? So bakit kailangan magganito? For security reason. So yung route ng 20 will be isolated to all users sitting on subnet 20. Na? So that is secure. Pero pagod ang CPU. No? So that's why if you type no route summary, okay, gagawin niya, sa-summarize niya to. So he will do route summarization computation. Similar to our topic sa route summarization. No? Para saan route summarization? To have an efficient way of routing. No? Magiging route summary nito, the one with the lowest subnet. Automatic. No, no need to calculate. Pero may calculation niya ginawa na. So yan ang magiging route summary. Okay? So pag binato mo, if you transfer packet here, anyone sitting subnet 10, 20, 30, 40, 50, no, will be reachable. Okay? Yun ang summarization. Malinaw ba? Any question about summarization? Okay, so RIP version 2, meron siyang auto summary and manual. Actually, lahat meron naman eh. AGRP meron, OSPF. That's why most depende no, depende sa company ninyo. That's why sa CCA-A OSPF natira. No, this is manual. Okay? So you have to define before you broadcast information. O di ba? Mas secure, no? Try to imagine if the hacker is sitting subnet 10. Okay, nakaupo dito. No? Or let's say subnet 60 which doesn't belong to any VLAN. Okay, or any subnet. Subnet 60. So that means hindi he won't be able to contact tong mga servers na to. Okay? Kung meron kang summarization. Ay, wala kang summarization. So how do you disable summarization? The command will be no summarization. No? Next, what will be the metric for RIP? Hop count, AGRP, combine hop count and bandwidth. No? The one with the fastest bandwidth. Then sum of delays. OSPF naman, sum of cost. Let's say you have 10 hops. Sum of calling cost. The one with the lowest cost wins. Okay? So how do you calculate cost? Meron tong table, no? If you have 1 gig, ito yung something like cost nito is 1 or something. No? Kung I'm gonna show you the table, meaning the one with the fastest bandwidth has the lowest cost. Okay? BGP, very complex. Timer update, meaning kailan siya nag-hello and kailan siya nagsisend ng dead interval. When you say dead interval, ito yung heartbeat na tinatawag sa VMware. Okay? So, once he found out na walang response, no, for 15 seconds, he will pronounce the path as dead. Okay? Hello naman, he's saying he would like to send an update. Okay? So sa RIP naman, version every 30 seconds. Okay? AGRP every 5 seconds sa local area. Pero pag 1, 1 minuto. Okay? Sa OSPF, triggered or every 30 minutes. Meaning, the moment you add router, dun lang siya magsisend ng update. O, di ba? Very efficient. Wala namang update, ba't ako magsisend every 30 seconds? Di ba? So, you're wasting bandwidth eh. No? So, an-experience namin yun eh. Tinanggal namin dalawang router, bumili si network. Eh, kaya pala eh, kasi RIP version 2, every sa isang minuto, no, sa isang minuto, dalawang hello. Paano kung 10 router nyo? Eh di 20 hello packets sinesend yan. You're building a huge traffic. No? Kaya iba OSPF ginagamit. So, nakita nyo yung difference? Na-feel nyo ba? Na-feel? Next, net size. RIP version 2 sa small. HRP large. OSPF large. That's why we're gonna be focusing sa OSPF lang. No? BGP is for ISP na. So, sa pinag-aaralan, RIP version 2, minove sa CCNP. Minove sa CCNP. HRP and BGP. No? So, tandaan nyo lang, classful, they do not send subnet mask info. Okay? They do not send yung slash. Dahil, automatic pag C, 254 kagad yan. No? And, hindi possible yung slash notation, which is variable length subnet mask, yung pa-ibang subnet. No? Okay, I'll give you an example. Ano bing classful? Tingnan nyo to. From router 1 to router 2, he's communicating via classful, which is /24. Ilang IP address sa /24? Nico. Ilang IP address sa /24? Yes, pamit lang yung mic. So, subnetting lang to, no? Sa /24 meaning 254 usable. Now, it's very inefficient. Why? Kasi he only needs one IP. Oh. Tingnan mo. From R1, papuntang R2. Kailangan lang niya dito 1 IP. So, ilan ang na-waste? Could be this one is 172.16.2.1. Kabila naman, 2.2. So, dalawa lang talaga kailangan mo. So, anong slash dapat dito? Slash? Anybody?
30.
30. Kasi 30 yields 4 IP addresses. 2 usable. Kaya dito, .1, dito naman, .2. 2 usable lang. So, hindi efficient to. Ba't ka maglalagay ng /24? Di ba? If you're observant, you can see lahat flat to. /24. Walang nangyaring subnetting. Walang VLSM. Subnetting the subnet. Kaya hindi efficient to. Okay, nagets nyo na? Koning classful. Malinaw, no? Malinaw. Okay, I hope it's clear. Next, classless. Classless includes subnet mask. Meaning, tanggalin nga natin. Pwede kang /notation. Yun ang CIDR. Pwede kang subnetting the class C, which is variable length subnet mask. So, instead of /24, gagamitan natin ng /30. In fact, lahat ng lab natin, puro tayo /30. Kasi wasted yan. Daming tapon na IP in Tagalog. Kaya yan, yan ang more efficient way of subnetting. Na-feel nyo na? Ano difference ng classless sa classful? No? Okay? Na-feel nyo na? Na-feel nyo na? /30, /30, /30. Kaya routers, /30 usually. No? Next, what do you mean by convergence? Convergence, the network has fully converged when all routers have complete and accurate info about the network. Meaning, if this one has 100 routes, tapos to 30, hindi yan fully converged. So every 30 seconds, magsisend to, if RIP, kakopy nyo yung 90 missing. Pag nag-replicate na sa routing table, 90, let's say 100, fully converged na siya. Okay? Malinaw? So, meron niya acknowledgement. So, papakita ko mamaya sa actual. Convergence. So, what do you mean by convergence? Again, no? So, paulit-ulit. That's one way to learn, no? Because repetition is the master of repetition is the best way to learn, no? Routers must share routing info. Ano ginagawa ng router? They share info. Sometimes called dynamic learning, no? Convergence, the router must calculate the best path. So, ito yung tinatawag ng path determination. So, maraming formula sa path determination. The router must, in order to be fully converged, they must update routing table. Kung RIP to, every 30 seconds, nagbabato ng table. Okay? Okay? Or the moment you hit enter. So, convergence, generally slower sa RIP and faster sa EAGRP. Why? Bakit kaya? Bakit kaya? Kasi nga ito, yun ang protocol niya di ba? Yun ang protocol niya OSPF is using link state, meaning the one with the fastest bandwidth win. EAGRP naman is hybrid, meaning he's using metric hop counts. The less hop, the better. Okay? Same with RIP. Less hop, the better. Problema sa RIP, if you found na yung link na yon is very, very fast, he won't utilize that. Na kahit 10 gigabit pa yan, hindi niya gagamitin. Kasi sinusunod pa niya yung protocol niya na kung sino yung pinakamalapit. Malinaw ba? No, kaya mabagal lang ang RIP na. Purpose ng metric. So there are times when a router will have multiple paths to the same destination. Okay? So let's say from router 1 going to PC2, no? So merong dalawang routes from R1 to R2 to reach the PC2. Another route is R1 to R3 to R2 to PC2. Malinaw ba? So sino yung longest route? Bigger hops. R1, R3, R2. Mahabang hops yun. Sino yung short hop? Raymond. Sino yung short hop? The one with the lesser hop. Konting talon lang. Kasi ito, R1, so 1, 2 hops papunta dito. Gumagalaw ba yung mouse ko? Christopher Raymond. So, sino yung the one with the lesser hop? R1 to?
R1, R2.
Tama. Yan. Okay, so yung green. So, pag green yan, you are using, yan papakita ko. So, RIP protocol uses the one with the less hop. So, hindi yan pupunta dito sa R3, pupunta pa R2. Ganyan ang hop niya. Okay? Malinaw ba? Ganyan ang hop niya. So, network 172.16.2 is one hop utilizing R2. One hop lang 2 hops ng R3 to R2. Okay? So, inefficient. So, sa RIP, susundin niya tong one hop na to. Okay? RIP. Paano kung mabilis yung speed nito? Hindi niya susundin yun. No? Kung 10 gigabit to 64, dito pa rin siya. Malinaw ba? Malinaw. So, in RIP, I will use this route. The one with shortest hop. Okay? Malinaw? Next. What about link state protocol? So, one protocol is open shortest path first, which is OSPF. Okay, so it uses bandwidth as metric. So, the one with the fastest speed, T1 is 1.5 megabit per sec. Ito na ang 56 kilobit per sec. Mabagal to. So, ang gagawin yan, no, sabihin niya, the route to 2.0 is through R2. 56 ang R2, 1.4 ang R3. So, ito, mabagal. Ito, mabilis. Hence, it will use the green arrow. Okay? So, tatalon siya sa R3, pupunta sa R2. Yun ang OSPF. Malinaw ba? Malinaw? I hope it's clear because I use PowerPoint. So, ganun sa Nexus. If you're gonna enroll sa Nexus, meron kaming PowerPoint to demonstrate. No? Hindi lang basta lab. So, 30-minute discussion, 30 minutes question and answer, tapos 30 minutes demonstration, then 30 minutes hands-on lab for you to practice. So, pa-practicing nyo to later. No? Because experience is the best teacher. Okay? So, I will use this route. Yan. Metric field in routing table. The routing table display metric for each dynamic and static. Okay? Static route is always 0. Okay? So, table 0, 0. No? Dynamic route, the one with the lowest metric. So, let's say ang scenario is from R2, then destination PC4. Let's say gusto kong pumunta dito sa PC4. Ang subnet ko is 3.0. Tatawid ako ng 4.0, 7.0, 5.0 before reaching 8.0. Dami, no? Daming dadaanan. No? Okay? So, if you're gonna type show IP route, this is the command to verify the route. You will see may R. So, when you say R, this is a RIP, Dynamic Routing Protocol. Okay? So, anong hops niya? 1.0, 2.0, 3, 4, 5. Kasi lahat dinaanan. And then, C pala, meaning direct connect. Direct connect yan. Meaning, tumawid sa serial. Tingnan nyo, 2.0. Hanapin natin. 8, 7, 4, ayun, 2.0. So, meron tong direct connect using serial port. No? Same with 3.0. Direct connect. Serial. Could be gigabit. Ayan, fast ethernet. Nakita nyo? Fast ethernet. Serial sa 1. Fast ethernet LAN. Kaya tingnan nyo R2. So, nakaka-connect sa switch using fast ethernet. Could be 100 megabit or 10 megabit. Okay? So, nakikita nyo yung path. Huh? Next. 4.0. So, dito naman, connectivity nito R2 to R3. Subnet 4, ginagamit niya. Ayun, no? So, connected naman siya using serial interface 0/1. Okay? Kasi ito, interface 0/1. So, dito naman, papuntang R3. Anong port tumakbo? Saan lumabas? 0/1. Malinaw ba? Yung 40, ito, subnet 4, tumawid is directly connected to serial 01. Okay? And then, ano pa? 5.0. May link daw siya sa 5. Ayun. So, question dito, sino ba to? R2 to. Ito yan eh. Sabi niya, sir, how did he found out na may route na 5.0? Hindi naman nakalista dito sa akin. So, when you say neighbor, 1 hop away. Okay? So, ito, hindi na to neighbor. Pero, how come meron siyang, how did he found out nga? Paano niya na-copy ito? Paano niya na-replicate yung 7.0? Kasi hindi naman niya neighbor, using dynamic learning, no? Ito yung tinatawag na dynamic learning. So, R4 will send network broadcast to R3. R3 will send broadcast to R2. So, he dynamically learned. Okay? Hindi to manually added. Malinaw ba? How did it learn? It learned dynamically using RIP protocol. Okay? And then, meron dun 8. Okay? He found out na subnet 8 routing information is written on router 4 table. Router 4 broadcast the information to router 3. Router 3 broadcast the information to router 2. Hence, nag-fully converge siya. Kaya lahat ng route na dinaanan niya has been written dito. Sulat niya lahat 1, 2, 3, 4, 5, 6, 7, 8. Nakita niya? Lahat, di ba? Malinaw. So, yun ang dynamic learning. So, how do you verify? Show IP route. Tandaan niyo yung command na yan. It's very important. Later on, you're gonna be having a problem. How to display uli yung route? Show IP route. Okay? So, all routers are running RIP kasi may R. R2 has a route to 8.0. 8.0. 8.0. Router 2. Ilang hops? 1, 2. 2 hops away. Malinaw ba? 2 hops away. Kung ilang router, when you say hop, the number of router. Malinaw ba? Okay, what about load balancing? So this normally happens if 2 or more routes is reaching the same destination. Tingnan nyo. Router 2, gustong puntahan si PC5. So pwedeng pumunta sa kaliwa, pwedeng pumunta sa kanan. Okay? So yung route, if you type show IP route, lalabas niyan 120. 120 is the admin distance /1, meaning 1 hop away. Okay? 1 hop away to subnet 2. Okay? Ito subnet 4. Ayan, subnet 2, dito siya dumaan. Malinaw ba? Ayan. And subnet 4, ayun, dumaan sa kanan. Load balancing yan. So the router will perform load balancing among all equal cost path. Kung pareho yung cost. If the cost is 10 dito 100, the one with the lowest cost. Dito lang gagamitin. So sabi dito, ilan? Equal. Okay? Equal siya. What is admin distance? Admin distance, the measure of reliability. When you see C, no, zero distance, no, lalabas dito 0. Tingnan nyo, tingnan nyo ito. Ito connected to, connected din. So, as you can see, wala siyang admin distance, pero admin distance ng direct connect is, or static is 0, no, or 1. So, dito 1, kasi R, 1 hop away, no? Ayan, naka-connect 0, using different interfaces. Okay? So, admin distance, measure of reliability. So, pag sinabing static, 1. No? RIP naman, 120 admin distance. Sorry, ito pala. 120, admin distance, 120. No? So, ano ulit AD? Measure of reliability. The one with the lowest AD is more reliable kasi ito, direct connect. Mababa. So, highly reliable. Kasi direct connect yan eh. Meaning, from here to here, direct connect yan, connected. So, how does it resemble on direct connect? C lang, C. No? Direct connect yan, C. So, dito naman, meron tayong 120. Ayan. Malayo na yan. No? Malayo na masyado. Lalo na yung external EIGRP. No? The highest AD, the less reliable. Okay? Again, what is admin distance? Admin distance is the feature that router use in order to select the best path when there are two or more different routes to the same destination from two. Admin distance defines reliability of a routing protocol. Okay? Gaano ka-reliable? So, sino mas reliable in this one? RIP or OSPF? Adrian. Sino mas reliable? RIP protocol or OSPF? Tandaan nyo, the higher the number, the less reliable. The lower the number, the more reliable. Ano kaya sagot, Adrian? Tama, OSPF. Mas mababa yung admin distance niya. Okay? So, admin distance defines the reliability of routing protocol. Routers learn about adjacent, meaning yung neighbor, no, that are directly connected, about remote network by using static. So, when you say static, direct connect, ayan, 1. Admin distance, 1. No? So, static admin distance is 1. OSPF AD is 110. As you can see dito. Okay? 110. Malinaw. So, in multiple routing sources, it's best to determine the one with the lowest admin distance. The static route will be added to the routing table and normally have an AD of 1. Okay? So, multiple routing sources, let's say pinaghalo-halo, EAGRP, RIP, no? So, while not as common, R2 above has learned routes to network 6 from EAGRP and from RIP. So, sabi dito, yung R2, this R2, learn routes from network 6. Asa yung 6? 7, 4, natakpan niyo. 4, ayun, 6. Okay? So, in a load balancing scenario, anong path, which path does the route taken? Yun ang tanong dito. So, ano ginamit niya? EIGRP o RIP? Let's say, dalawa yung define mo dito. Sa kaliwa, EIGRP, papuntang this router. Sa router 3 naman RIP. No? So, ano ginamit dito? So, sabi dito, while not as common, no? EIGRP kasi 90. Samantalang RIP is 120. So, ano ginamit? Yung EIGRP. Okay? So, pag different protocol, nagkakaroon ng conflict, it will still perform a best path determination. In this case, yun yung best path. The one with the lowest admin distance. Okay? Kasi RIP is 120, di ba? Ang admin distance sa EIGRP is 90. Mas mababa to. So, the route learned from EIGRP will be installed in the routing table. So, dito ilalagay niya. So, ang route code will be R1, hindi R3. Malinaw ba? Malinaw. So, hindi pwedeng sabay, ha? Hindi pwedeng sabay. So, kaya nga merong path determination in a load balancing scenario, eh, no? Paisa-isa yan, no? Paano kung dalawa ISP? Different story na yun, no? Gagamit ka na ng gateway load balancing. So, meron kaming lab doon, no? Let's say may PLDT, tapos meron kang globe. Pwede bang sabay, no? Eh, isa kasi 50, isa naman 100 megabit. Pwede bang sabay, di ba? Kailangan yung load balancer nun. Okay? So, if you type route, show IP route, you will see directly connected. Okay? If you type show IP protocol, it will display the routing protocol you're using plus the process ID. So dito, nung tinype tong protocol na to, lumabas yung routing entry niya. Yun, no? Route 2, subnet 2, subnet 3, subnet 4. O, distance 90. Anong protocol to? Anybody? Anybody? Nico. Distance 90. Anong protocol to? Admin distance 90. Anong protocol? Kanina, ayun na 90. Internal EIGRP. Tama. No? Ito naman, distance 120. Anong protocol to? Admin distance. Actually, makikita nyo dito. Ayan, sa taas lang. RIP. EIGRP. Okay? So, ganun pagbasa. Anong gateway IP address? 2.1. Dito naman, 4.1. Okay? So, ganun lalabas. No? So, if you would like to display anong routing protocol, what's the command? Francis? I would like to find out anong protocol tumatakbo sa router 2. Anong command? Show IP protocols. Okay? Okay, so napakahaba. Mag-lab na tayo. Ayun, tapos na pala. Tapos na. Okay? So, yun ang ating dynamic